The objective of today's lesson is to describe the tidal cycle that occurs on Earth due to the gravitational interaction between the Earth and Moon. This diagram is at the top of your guided notes. It describes Newton's law of universal gravitation. This law of gravitation states that the force of gravity acts between all objects. So we know that gravity is what keeps us down to the ground. It's what causes things to fall. But if mass increases, so that means if an object gets larger or heavier, the force of gravity increases. So we can think of this with our barycenter. We know that objects with greater mass, the barycenter will be closer to that because the force of gravity and the center of gravity will be closer to the object with larger mass. So then if distance increases, the force of gravity decreases. So we know this when you move further away from the sun, the orbital period is much shorter and the planet will move a lot slower because the force of gravity decreases. Okay, so in today's lesson we're learning what tides are. So what are tides? Tides are the daily changes in the elevation of the ocean's surface. So when you are at a beach or near a lake, you notice that there are tides. So that's when the water is coming in and out. So there are three things you need to know. Tidal range, which is the difference between high and low tide. And low tide is the water level minimum, so that's when it's at its very lowest. And high tide is the water level maximum, which is when it's at its very highest. So what do ocean tides result from? The first is the gravitational pull exerted upon Earth by the moon and to a lesser extent by the sun. So the sun does have some effect on this, but it's mainly by the moon. So a word worth knowing is exerted. You probably haven't heard the word before, and if you have, that's awesome. Exerted means to apply or bring to bear a force, influence, or quality. So to use this in a sentence, Shane exerted all his energy by working out after he ran 2 miles. Okay, so I want you to copy this diagram into your guided notes. Feel free to pause this just so you can see this. Once you're done, feel free to unpause and move forward. So even though the sun is 10 million times more larger than the moon and is 390 times further away, the moon is 390 times further away, the moon actually exerts a gravitational pull that is 2 times greater than the sun. It's very interesting. So what we know from that is about every 7 days, Earth alternates between 2 types of tides, a spring tide and a neap tide. So a spring tide occurs when the Earth, Moon, and Sun are in line. So this is the Moon, this is the Earth, this is the Sun. So they're in line. So that is when a spring tide occurs. So in contrast, there's something called a neap tide. So that's when they're at right angles. So you see the moon is here, here's the Earth, here's the sun. So it's a right angle. And in contrast, in the first quarter, the moon is here, Earth is here, the sun is here. That's another right angle. So that is a neap tide. So this is just another diagram that shows you that. This is a spring tide. So remember the moon, the Earth, sun are in a linear movement, like a linear movement. Well, not movement, a linear path. It's in line. And then a neap tide is at a 90-degree angle. So you see the moon, the Earth, the sun. Moon, Earth, sun. Okay? And so what we know is that spring tides actually cause the greatest difference between your high tide and low tide. So your spring tide on this graph is represented by the solid white line. And neap tides cause a smaller difference, so that's your dotted yellow line. Okay? So key points from today's lesson. The results of tides is the gravitational pull exerted upon Earth by the moon and to a lesser extent by the sun. When the Earth, moon, and sun are all in line with each other, spring tides are experienced. And when the Earth, moon, and sun are at right angles to each other, neap tides are experienced. So that's it for this lesson. Make sure you complete your guided practice and your exit ticket. Thanks, guys. Bye.